Hey there, future mathematicians. Welcome to a journey that will change the way you see the world around you. Today, we embark on an exciting adventure into the realm of mathematics, where numbers and equations come to life in ways you never imagined. Get ready to explore the exciting world of functions. Functions are like the secret language of the universe, helping us decode the mysteries of how things work. They are the building blocks of many concepts in math and science, and once you understand them, you'll see their magic everywhere. Don't worry, it's not as scary as it sounds. In fact, learning about functions can be a lot of fun. Think of it as solving a puzzle where each piece fits perfectly to reveal a bigger picture. With a little bit of practice and curiosity, you'll soon find yourself mastering these concepts with ease. In fact, functions are everywhere in our daily lives. They are not just abstract concepts confined to textbooks. From the moment you wake up to the time you go to bed, functions play a crucial role in your daily routine. They help us make sense of the world and make informed decisions. Think about it. The number of hours you work and the money you earn, the relationship between these two variables is a function. The more hours you work, the more money you make. This simple yet powerful concept can be applied to countless scenarios in life. Or consider the temperature outside and what you wear. These are all related. When it's cold, you wear a jacket. When it's hot, you opt for lighter clothing. This relationship between temperature and clothing choice is another example of a function at work. Functions help us understand and describe these relationships using the power of math. They allow us to predict outcomes, make better decisions, and solve problems efficiently. Excited? Let's dive in and uncover the wonders of functions together. As we delve deeper into the world of functions, you'll learn how to identify different types of functions, how to graph them, and how to interpret their meanings. You'll see how functions can model real-world situations and help us find solutions to complex problems. You'll also get the chance to work on exciting projects and collaborate with your classmates. Together, you'll explore the practical applications of functions and see how they can be used to tackle real-life challenges. Whether it's in science, engineering, economics, or everyday life, functions are an essential tool that will empower you to think critically and creatively. With the help of technology, learning about functions has never been more engaging. You'll have access to interactive tools and resources that will make the learning process dynamic and enjoyable. From graphing calculators to educational apps, these tools will enhance your understanding and make math come alive. So, are you ready to embark on this math adventure? Together, we'll unlock the secrets of functions and discover the incredible ways they shape our world. Get ready to be amazed, inspired, and empowered. Your math adventure starts now. Imagine a magical vending machine. Not just any vending machine, but one that can give you exactly what you need whenever you need it. Picture it standing there, gleaming with bright lights, inviting you to make a choice. You put in $1, that's your input, and you eagerly wait for the machine to work its magic. The anticipation builds as you hear the gears turning inside, and out pops a delicious candy bar. That's your output. It's exactly what you wanted, and it feels like a small miracle every time. The process is simple, yet fascinating. Functions work the same way. Just like the vending machine, they take something you give them and transform it into something new. It's a process that happens all around us, often without us even realizing it. They take an input, do something to it based on a rule, and then produce an output. This rule is like the secret recipe that the vending machine uses to create the perfect candy bar. This rule is the heart of a function. It's what makes the whole process work. Without it, the machine would just be a box with no purpose. It tells us exactly how the input and output are connected. It's like a map that guides the input through a series of steps to become the output. For example, let's say our function machine doubles any number you put in. This means that whatever number you give it, the machine will multiply it by 2. If you input 3, the machine doubles it and outputs 6. Cool, right? It's like having a superpower that can instantly transform numbers. But functions aren't just limited to doubling numbers. They can follow any rule you can imagine. Some functions might add a certain number to the input, others might subtract, multiply, or divide. There are even more complex functions that can involve multiple steps and rules. Think about all the different ways you can transform a number. You could square it, take its square root, or even apply a combination of operations. The possibilities are endless, and each function has its own unique rule. Imagine a function machine that triples any number you put in. If you input 4, the machine will output 12. Or a machine that subtracts 5 from any number. If you input 10, the machine will output 5. These function machines help us understand how different rules can change the input in various ways. It's like having a toolkit of different machines, each designed to perform a specific task. In the real world, functions are used in countless applications. From calculating interest rates in finance to determining the trajectory of a rocket in physics, functions are everywhere. They help us model and solve problems, making sense of the world around us. By understanding functions, we can predict outcomes and make informed decisions. So next time you see a vending machine, remember the magic of functions. Just like that machine, functions take an input, apply a rule, and produce an output. It's a simple yet powerful concept that underlies much of what we do, and who knows, maybe one day you'll create your own function machine to solve problems and make the world a better place. The possibilities are endless, and it all starts with understanding the basics. Keep exploring, keep learning, and keep discovering the magic of functions. They're all around us, waiting to be uncovered and understood. Happy learning. Functions love to show off in tables and graphs. They are like the rock stars of the math world, always ready to perform and reveal their secrets. When you look at a table or a graph, you're essentially getting a backstage pass to see how these functions operate. It's fascinating to see how they transform input values into output values, creating a beautiful dance of numbers and patterns. In a table, the input values are usually listed on the left, and the corresponding output values are on the right. This setup makes it easy to see the relationship between the inputs and outputs. Imagine you're a detective, and each row in the table is a clue that helps you understand the function's behavior. By carefully examining these clues, you can start to see patterns and make predictions about what the function will do next. It's like solving a mystery, one piece of data at a time. If each input has exactly one output, you've got yourself a function. Graphs work similarly. When you plot the points on a graph, you're creating a visual representation of the function. Each point on the graph tells a story about how an input value is transformed into an output value. It's like connecting the dots to reveal a hidden picture. And just like with tables, you can use graphs to spot patterns and make predictions. The more points you plot, the clearer the picture becomes. Each point on the graph represents an input-output pair. These pairs are the building blocks of the function, and by examining them, you can gain a deeper understanding of how the function works. Think of each point as a piece of a puzzle. When you put all the pieces together, you get a complete picture of the function. And just like with a puzzle, the more pieces you have, the easier it is to see the big picture. The input is usually on the horizontal axis, x-axis, and the output is on the vertical axis, y-axis. This setup helps you see the relationship between the inputs and outputs more clearly. By labeling the axes, you can keep track of which values are which, making it easier to interpret the graph. It's like having a map that shows you where everything is. With this map, you can navigate the graph and understand how the function behaves. A graph represents a function if it passes the vertical line test. No vertical line can intersect the graph more than once. This test is a quick and easy way to check if a graph represents a function. If a vertical line intersects the graph at more than one point, it means that there are multiple output values for a single input value, which is not allowed in a function. By using the vertical line test, you can quickly determine if a graph represents a function or not. It's like having a litmus test for functions. See, functions are like hidden treasure waiting to be discovered in tables and graphs. By carefully examining the data and using tools like the vertical line test, you can uncover the secrets of these functions. It's a thrilling adventure that combines logic, creativity, and problem-solving skills. So grab your magnifying glass and get ready to explore the fascinating world of functions. Who knows what treasures you'll find along the way? Let's dive deeper into the world of functions with a magical twist: transformations. Imagine functions as magical wizards that can morph shapes and numbers. These transformations can stretch, compress, shift, or even flip the graphs of functions, creating endless possibilities. First, let's talk about shifting. Picture moving a graph horizontally or vertically. When you add or subtract a number to the input, x value, the entire graph shifts left or right. Similarly, adding or subtracting a number to the output, y value, moves the graph up or down. It's like sliding a picture frame along a wall, keeping the image intact but changing its position. Next, we have stretching and compressing. By multiplying the input or output by a number, you can stretch or compress the graph. Multiplying the input by a number greater than 1 compresses the graph horizontally, while a number between 0 and 1 stretches it. For the output, the opposite happens. Multiplying by a number greater than 1 stretches it vertically, and a number between 0 and 1 compresses it. It's like zooming in and out on a photo, altering its proportions without changing the core image. Finally, let's explore reflections. Reflecting a graph over the x-axis or y-axis flips it like a mirror image. By multiplying the input by -1, the graph reflects over the y-axis. Multiplying the output by -1 reflects it over the x-axis. This creates a symmetrical transformation, showing how functions can mirror each other. These transformations are like tools in a magician's kit, allowing you to create and manipulate graphs in fascinating ways. By understanding these concepts, you can uncover even more secrets of functions and how they behave. So grab your wand and let's continue our mathematical adventure.